This is for Year 12 Specialist. It comes out of 6G question 15 in Spec. Sketch the graph of the following, labelling all features. Okay, looking at this particular equation, I can see that I can factorise the numerator into x outside of x squared minus 3, which factorises into x minus root 3, x plus root 3. Therefore, when y is equal to 0, I have 3 x-intercepts. So x-intercepts at x equals 0 and plus or minus root 3. And when the denominator is equal to 0, x equals 1. But because the denominator can never equal 0, that gives me a vertical asymptote at x equals 1. So there's a couple of things I know about my graph so far already. At 1, I have an asymptote. I have an x-intercept at 0. Root 3 is about 1.7, so at positive root 3 and at negative root 3. Okay, because I have a cubic divided by a quadratic, I'd like to do a polynomial division to put it into the correct form. So I've got x squared minus 2x plus 1 divided into x cubed minus 3x. X squared goes into x cubed x times. X times that is x cubed. X times that is minus 2x squared. X times that is plus x. Subtract, that gives me 2x squared minus 3 and minus 4x. X squared goes into 2x squared plus 2 times. That goes into that 2x squared. 2 times that is minus 4x. 2 times 1 is plus 2. Subtract the second one from the first, and negative 2 is my remainder. So this is the same as y equals x plus 2 minus 2 over x minus 1 squared. So in effect I have the addition of a linear x plus 2 and a truncus minus 2x minus 1. So I've got a truncus that looks like this, and this going through at 2, negative 2. So I'm adding these two things together. So my curve is going to, I know it's going to cut through there, so it's going to approach that asymptote down there and approach that line of y equals x plus 2. And I'm going to have, this is going to approach negative, and negative plus a negative, so we're going to approach this here, and we're going to go up like that, down like that, and down in here. That's what my curve's going to be. It looks as if I have one turning point. I know that's negative root 3, 0 and root 3. I need to find that turning point. So I need to take the derivative to find the turning point. Okay, so I've done that. I've used the quotient rule, and I've only considered my numerator, because if the derivative equals 0 to find a turning point, I can ignore the denominator. But I get this pretty awful cubic that I need to factorise. Then I look at their answers and they haven't labelled the turning point, because really it's a technology allowed question to label the turning point. But everything else that I've got there is exactly the same as what I've got here. So I'm pretty happy with that graph, really. I've got my x-intercepts, I've got my y-intercepts, I've got my asymptotes. So x equals 1 is one asymptote, and y equals x plus 2. But the big trick was do a polynomial division when you have a cubic divided by a quadratic.